All right, so let's talk about derivatives. The derivative of a function just tells you how that function is changing with respect to x, right? So if x is the variable in that function, we want to know how does f change as x changes. Okay, so the definition of a derivative is given here. Whoops. And essentially, though, it's the change in the function over the change in x, right? So this h is actually the change in x. And we could think of, if we call y equals f of x, this is delta y, right? So it's the change in y over the change of x, which is the slope of the function, right? And it's just that we're allowing the change in x to get smaller and smaller. So we're taking the limit as that change in x goes to 0. Okay, and that gives us the instantaneous rate of change of a function. Okay, so this is something that's not new to you. I'm sure you went into this in depth in 108. So the rate of change is the instantaneous rate of change, which is also the slope of the function. All right, so slope. That's important to think of the derivative as being the slope at any given point. Now, if we take the derivative of the derivative, we get the second derivative, okay? And that tells us how the slope is changing with respect to change in the variable x, right? So, and that tells us something about the concavity, all right? So I have our rate of change, our slope, and our concavity of a function can be either positive or negative. So we have 4 different scenarios that we can end up with. A function can be concave up and decreasing. It could be concave up and increasing, or concave down and decreasing, or concave down and increasing. All right. So this gives you a little bit of a visualization of what that looks like. So, for example, in this first scenario, we have it's decreasing, right? So the derivative is less than 0, but it's concave up. So the second derivative is greater than 0, which means that the slope is increasing. Now that looks interesting because this is a negative slope, but you can see it's becoming less negative. So the slope is increasing, right? As opposed to over here, we have a positive slope, right? So it's an increasing function, and the derivative is greater than 0. And in here also, the second derivative is greater than 0. Both these cases on the top here are cases of concave up functions, but you can see here the slope is increasing in the positive direction, right? So it's a little more clear. You know, down here you've got a slope like that, whereas up here you got a slope that's a little steeper. Okay, so it's increasing in the positive direction instead of decreasing in the negative direction. But either way, the slope is or the second derivative is positive. It's concave up. Down here below we have a case of a decreasing function, right? So it's a decreasing function, which means that the derivative is less than 0, right? It's negative, right? And here it's concave down, so the second derivative is also negative. Okay, so you can see here, if you look at the slope, it's it's fairly shallow, and it's becoming, but it's negative, and then it's becoming more negative down here, right? So even though the slope is steeper, it's getting steeper in the negative direction, which means that the second derivative is negative. Okay, and then over here we have a case where we have the first derivative is greater than 0, right? Because it's an increasing function, and the second derivative is less than 0 because it's concave down, and here you can see it's positive. So here you've got a slope that looks about like that, and it's becoming more shallow, right? So it's decreasing in the positive direction, right? The slope is always positive. All right, well, that gives you a little bit of an overview. In this first example, what I want you to do is sketch the graph of the derivative given a graph of the function itself. Okay, so we're given the function, and we don't know what the formula is. We just have a graph of it. So basically, what we're doing is graphing the slope. Okay, we're graphing how the slope what the slope is. Now, this first example is pretty straightforward. It's just a straight line, and the slope, if I just take a couple of points and I say, okay, well, to go from this point at 1, 0 up to this point over here at 2, 2, looks like I went up 2 and over 1, so my slope is equal to 2. Okay, so if I'm going to graph that, graph the derivative of that function, then it's just going to have a slope of 2. It just has the slope is 2, so the value of the derivative is just 2. It's just going to be constant over the what we know, right? Now this function, I don't really know anything outside of the interval between -1 and 3, so I can really only graph it, between -1 and 3. But the way I would graph it is just a positive 2. And I'm going to put an open circle here because I don't really know anything what's going on less than -1. And then I'm going to put an open circle here at 3. And I'm just going to graph a constant 2, right? Because the slope is just 2. It's a constant slope. All right, let's take a look at this next one. This is a little more interesting. Now, when I do these problems, what I normally do is, first of all, look for any place where the slope is 0. Okay, wherever the slope is 0. Now, I can see that this function, it looks like it's positive, and then it switches direction, right about here. And this place where I'm switching direction in the slope is where it's 0. So if I drew a tangent line at that point, I would give us a slope of 0. Okay, and then the function is decreasing, right? And then I have another change in direction down here. So this point where it changes direction from decreasing to increasing also has a slope of 0. Whoops, equals 0. Okay, so I'm going to plot those points first. So when I'm plotting the derivative, I'm just plotting the slope. So I know that the slope will be 0 at those 2 points. So I can plot those 2 points right here and right here. Okay. And now I just want to look at, okay, where's it increasing? Where's it decreasing? All right. Now I can see that it's increasing, right? So here it's increasing. So here the derivative is greater than 0. So when I graph the derivative of the function, it's going to be above the x-axis. In here, the between 1 and 2, it looks like the slope is negative, right? So it's less than 0 between 1 and 2. So when I graph that, when I graph the slope, it's negative, which means it's below the x-axis, all right? And then again, it's positive out here. So the slope is positive, and then it's going to be above the x-axis again. So, you can kind of estimate what the slope is. If I look at, okay, I have to go from here to there, right? So it's about, I'm kind of going down by about 2.5 and over by 2. So it's a little more than 1. So, but it's negative, right? So it's going to be a little more than -1. It's not that important to be accurate about your values. Just kind of get the general shape. All right, so I know that it's increasing, so it's going to be above the x-axis here, right? And then it's negative between 0 and 2, and then it has to come back up to 0, okay? And then and then the slope is positive again, so it's going to be above the x-axis. Whoops. All right. So there's kind of a sketch of what that derivative looks like, roughly. Okay. So now, you can see here too that, well, you could also look at the concavity, but yeah, it's not really necessary, I guess. You really just need to, know where the slope is positive, when it's negative, and graph it accordingly. So, I would say you could pause the video here. I'm going to go ahead and go through the other 2 examples, but I would say you should pause the video and give it a try yourself, and see if you can graph parts C and D. All right, so hopefully you've had a chance to take a look at these. Now, again, for C, okay, C, the first thing I'm going to do is look for wherever I have a change from increasing to decreasing or decreasing to increasing, right? So it's going to pass through 0. So I'm looking for wherever the tangent line is a 0 slope. That's usually where I start with these. And I know that here and here, right? The slope is 0, right? So here I'm going from decreasing to increasing, and then I'm increasing, and then I switch from increasing to decreasing. All right, so let's plot those 2 points. I'm going to go down below. It's too bad I can't got them both on one screen. But let's plot those points. So it looks like it's not quite 1. I'm going to pass through 0 here, and the other one is at about a little more than 1. So it looks like I'm going to pass through 0 here as well. Okay, so now let's look at where the slope is positive and where it's negative. Where is it increasing and where is it decreasing? So it looks like it's decreasing over here to on the left-hand side of the curve, right? This is obviously a negative slope over here, right? So it's decreasing over here. So that means it's going to be below the x-axis. After this place where it crosses 0, it's going to be positive, right? So here the derivative, which is the slope, is greater than 0. So it's going to be above the x-axis, and then over here it's less than 0. Okay, so I'm going to be below the x-axis again when I graph the derivative. Okay, it looks like it's fairly steep in the middle, so I'm going to guess, somewhere probably peaks up around 3. So it's positive between these 2 0 points. So it's just going to peak up here, spike up, and then come back down. Now you don't have to be that accurate with how far it spikes up, right? So, but I know it's going to look something like that between the 2 points where the slope is 0. And then I'm below the x-axis. But let's take a look at what's happening here. It looks like, it's fairly shallow at first because we're coming out of 0. It becomes a little steeper. And then over in this region, it looks like it's becoming more shallow, right? And maybe even approaching 0. I can't see enough of the graph, but it looks like same thing over here. It seems like the slope is becoming more and more shallow. So it's like approaching 0. So what's that going to look like? All right, well, it's going to come down, and I'm not exactly sure where this point turns, but eventually it's going to kind of it looks like it's approaching a very shallow slope, approaching 0. And it looks like it's fairly symmetric too. If I look at the other side, it's kind of doing the same thing. If I work backwards from this this point where the slope is 0, it kind of looks like it's doing something very similar on the other side. So I'm just going to try to sketch what that looks like. Right? And then it's getting more and more shallow. So I would say that the derivative would look something like that. All right. So that's my best guess. All right. So let's do one more. This one's pretty straightforward. We just have straight lines, right? So I know when I have a straight line, the slope is constant, and which means the derivative is a constant. So let's try and see what this, figure out what the slope is of these 2 pieces, right? We've got a piece that's less than 2, another piece over here that's where x is greater than 2. So it kind of looks like I'm going, to go from one point to another, I'm going, down 1 and then over 1, right? Down 1 and then over 1. So it looks like the slope is 1 over here, or I should say -1, right? Because I'm like down 1 and then over 1, down 1 and over 1. So it's a negative slope, right? And it looks like it's about -1. So that's good. Now, once over here on the other side, where x is greater than 2, looks like I have to go up 2 and over 1, right? up to and over 1. So it looks like over here I have a slope of 2. Okay, so the derivative is just the slope. So we're just going to plot those values down here. So it looks like we're changing it too. So, and I didn't really, the slope is kind of undefined at that point. So I'm just going to put an open circle here at 2, and I know the slope is 2 to the right, and it's -1 to the left. Okay, and it's just constant, right? So I can draw a straight line, right? So that's sort of what it would look like. All right, so there you go. And I will meet you in the next video.